Hey, Algebra 1. Today we're going to look at lesson 1.5, solving equations with variables on both sides. And you might be asking yourself, well, wait a second, wasn't that 1.4? Well, you would be correct. But today, objective number 2 is a little bit different than what we've seen before. It says identify special solutions of linear equations and inequalities. And in class, I had you guys try some problems, and they found out that sometimes the variables just like disappeared. Well, when that happens, that means the variables really didn't, what you put in for the variables really didn't matter. And it's kind of interesting. And either it didn't really matter because no matter what you put in would get you no solution. It would never work. Or sometimes what you put in didn't matter because no matter what you put in, it would always be correct. So all numbers work. And in the math world, we get a little more specific. We say all real numbers work. It turns out there's imaginary numbers, which I know sounds ridiculous. I don't know why they came up with that name. But anyway, there's imaginary numbers in the world. And then also you'll see people say infinitely many solutions, which in some cases in algebra, that is a better answer. But yeah, I would accept that in these cases as well. It's probably more accurate to say all real numbers. And then additionally, you'll hear people say when it's all real numbers that they'll say it's an identity. An identity. So it's kind of an interesting, some interesting vocabulary there, but you can just pick one for whichever you prefer. So let's dive in and find out what we're talking about here. So distribute the 3 would be a good way to start that out because we're going to need to get those x's together. Can't get it together until that parentheses is no longer there. So distributing the 3 can help us out with that. But then what happens is we try to get the x's together and we quickly see that, whoa, they cancel out totally. Don't forget that if it cancels out totally on one side of an equation, you can put a 0. So we get 6 is equal to 0. Well, I don't believe I have to tell anybody that 6 does not equal 0. And what this means is since the variables went away, they didn't really matter here. And it turns out no matter what variable, what we put in for the variable, this is not going to work. And so that means we've got no solution. So if it's not true, we say no solution. Variable goes away, it's not true, no solution. Okay, so same deal over here. Probably start by distributing first. And you might be noticing, oh dang, look, it's the same on both sides. Well, so what happens is you try to get the y's together, and maybe at the same time you try to get the numbers together as well. But you're either going to get -2 equals -2, or if you try to get the numbers together, you'll get 0 equals 0. But either way, these are correct. These are true, totally true. So what it means is what y was didn't matter. It was always going to work. It was always going to be true. So we say all real numbers. And then for part C, it looks like we're doing kind of the same stuff here. Let's distribute the 2. Gosh, on this side, let's combine like terms, right? 1x plus 5x, that's 6 of them, 6 x's. Well, yeah, we'll simplify, we'll combine like terms a little bit more here. And try to get the x's together. Dang, go away again, don't they? Boom. We get 5 is equal to -10, which is not true. So we say no solution. Also, I do want to point out, You may have tried to get these together as well. You might have gotten 0 is equal to negative 15, not true. You might have gotten 15 is equal to 0, not true. So all of these are no solution. Do be careful, okay? A lot of times you'll see and you'll be like, oh dang, look, it's gonna cancel out. And then you'll make some math error here. When I grade these, I check here to make sure that's accurate and all the different possibilities. And then I also check here. So be careful, don't get into a rush. Now this next one's kind of interesting. I would encourage you to try this one on your own. But since it's a video, we'll just dive right in. Probably distribute the 2 first. When I say that, you could, if you wanted to, divide by 2 here, but then you'd have to divide by 2 to every term on the other side. It would totally be a nice way to do it, but I think it's more straightforward to distribute. But check this out. Try to get the x's together, they go away. And you're going to get negative 8 is less than negative 8. Or you might get 0 is less than 0. Is that true? Is negative 8 less than negative 8? No, not at all. It's not true. Not true. That's false. This is not true. So it turns out this is no solution as well. And then finally, class, let's do one more here. Looks like all of these are going to be special cases, I'm thinking. Yeah, looks like multiply the 4. You could divide the 4 anyway. But yeah, multiply the 4. And you'll get 8x minus 12, 8x minus 48. Subtract the 8x, subtract the 8x. Negative 12 is greater than or equal to negative 48. And class, this got a lot of my first hour. They got hung up on this. They said this was no solution. But let's think about a number line here. Negative 12 is going to be closer to 0 than negative 48 is. Negative 48 is more negative. So this is actually true. Negative 12 is greater than negative 48. So negative 12 is greater than or equal to negative 48. This is true. Now, if you really are like, man, I don't know about that. If it helps you to have positive numbers, add the 48 over. Keep it balanced. Add 48 here. And you'll get 36 is greater than or equal to 0. I don't think there's much argument about that. That is definitely true. So we say all real numbers. All right, well, these were all special cases today. Don't forget, they're not always all special cases, but if the variables eliminate completely, you evaluate the truth value of it. Is it true? Is it false? If it's true, it's all real numbers. If it's false, it's no solution. So have a good day.